Hey everyone, it's Princess here and welcome back to our channel. Today, we will be delving into the process of verifying your smart contracts on Ethereum. So verifying your smart contract is the key to unlocking its full potential. It will allow us to interact with our smart contract in the Block Explorer. So in this video, we will walk you through two methods for verifying those smart contracts. We will begin with the flattening of all the contracts into a single file, and then we'll proceed to the second method, which brings in standard JSON input, of course, utilizing hard hat. So let's get started. Okay, so let's begin with the flattening method. First, head over to Remix IDE or Integrated Development Environment. This is a web-based tool that we will use in creating and testing our Solidity smart contracts. Okay, now that Remix is now fired up, let's create a new file by clicking this icon right here and name it mytoken.sol. So this will be a very simple ERC721 smart contract. Okay, so let's write our code. First things first, let's declare the license identifier and the version of the Solidity that we will use. Then let's import three libraries from OpenZeppelin. Let me just paste it here. And then let's declare the start of our contract that inherits from OpenZeppelin. ERC721 and ownable. Then let's have our variables. There, and then let's declare the constructor of our contract that sets the name of the token to myToken and its symbol to MTK using the ERC721 contracts constructor. There, and then let's create the SafeMint function. So this function will allow the owner of the contract to mint new tokens. Let's have the address as its parameter, address 2, and then let's make it public only owner. Okay, now that we're done with our code, let's proceed to the Remix Compiler tab. So here in the Remix Compiler tab, click this arrow button right here to reveal the advanced configuration settings. Enable the optimization and leave it at the default 200 runs. Okay, so the runs refer to the number of times the Solidity compiler goes through the optimization process. So the optimization, this is where the compiler tries to make your smart contract more efficient in terms of gas usage and execution speed. So here, we set it to 200 runs, meaning the compiler will perform 200 iterations of this optimization process. Although higher runs may also improve the execution speed of your smart contract, we should also take note that higher run settings can significantly increase the compilation time, especially for complex smart contracts. So it may carry a slightly higher risk of unintended code transformations or issues that needed thorough testing later on. So we'll stick with a default setting of 200 runs for now, as it strikes a good balance. Okay, now let's compile and deploy our contract. Click this blue button right here that says compile mytoken.sol. And then you can also check here the autocompile to automatically compile your files whenever you make changes. Okay, I think I have a warning here and my SPDX license. Let me change this to here. Okay, so let's compile it again. Okay, now it has been compiled successfully. Let's go to the Deploy and Run Transactions tab. So here in the Environment section, change this to Injected Provider MetaMask to connect to our MetaMask wallet. And also, we are in the Sepolia test network. Okay, after that, let's click this Deploy button right here to deploy our smart contract. So your MetaMask wallet should pop up. Just confirm the transaction. And then let's wait for our smart contract to be deployed. Okay, our smart contract has been deployed successfully. Once deployed, let's copy the smart contract address, which is right here. Just click this copy icon right here. Okay, and then let's go to the Etherscan, Sepolia etherscan.io, since we are in the Sepolia test network. Since we already copied the smart contract address, let's paste it right here in the search input field. And then there. Here in the Etherscan, you can see here the different transactions that is associated with your wallet address or with your smart contract address. Now, I want you to navigate here in the Contract tab. And then you'll find a Verify and Publish option for source code verification. So let's click this. Okay, so once you're here in this page, we need to select the compiler type. Since we will use the flattened method, we will choose the Solidity single file from the options. Next is we will select the compiler version that we've used. Let's check it here in our Remix IDE. Go to the compiler tab. So we use the compiler 18 plus 87F. So let's look for it here, 18 plus 87F. Oops, there you go. And then we need to select the license type that we use, which is the MIT license. Okay, so double check everything. And if everything is correct, click continue. Okay, so after clicking continue, you'll see a page displaying the contract address, which is this one, the compiler version, and optimization setting. Since we enabled optimization earlier, let's set it to yes. Okay, here in the first input field, it says that we need to enter the Solidity contract code. So this is where we will flatten our code into a single file to simplify the process and avoid potential issues later on. So flattening the source code means merging all the dependencies and imported files into one file before verifying and deploying the smart contract. So let's go here to the Remix IDE. You'll see here, the code from all of the imported files will be moved to the main file. So it reduces the size of the contract and makes our debugging and verification easier as everything is stored into one file. So we don't need to track down the source of the imported code. Okay, so to flatten our code, let's go here in the File Explorer tab. Right-click the file that we created in Remix and then select Flatten. So a new file named my token underscore flattened or whatever your smart contract name is underscore flattened will be created. So let's open this file and you'll see here the flattened code. So we can see all of our codes merged into one file. So what we will do is we will copy everything, Control A and Control C, and then let's go back to Etherscan. Place it here in the input field. Okay, so there we go. The next one here is the constructor argument. This is usually automatically generated for you once you enter the flattened smart contract right here. Since we don't have any constructor arguments, let's just leave it blank. Also, here in the contract library address, we don't need to change anything here, so let's leave it as is. And the next is the MISC settings or the miscellaneous settings. The runs should be 200. Reflecting what we previously configured. The EVM or Ethereum Virtual Machine version to target is the compiler default, which you can also find here in the Remix compiler tab. Here, default. And the next is the license type, which is the MIT. Finally, let's click this I'm not a robot. And then this blue icon right here that says Verify and Publish. Okay, now let's just wait for the verification and publishing process to complete. If it succeeds, you should see a message right here that says successfully generated bytecode and ABI for contract address, and then it will display the contract address link. So you can click this contract address link to access your verified smart contract. So there, you can see here a green check mark on the contract tab. It indicates that your contract is now verified and published. Okay, so you can now interact with your contract and access the read and write methods here in Etherscan. So this is how you verify a smart contract using the flattened method. So another way to verify our smart contract is through the standard JSON input method. For this, we'll be using Hardhat and the terminal. So let's open our VS Code. I already created a folder here and installed the necessary tools and dependencies required to create a Hardhat project to speed things up. I also assume that everyone watching has Hardhat installed on their computers, as we've covered this in the previous videos. Or if you don't have one yet, you can check our previous videos to know how. Or you can also check the Hardhat documentation. The link will be sent in the description box below. Okay, now that our Hardhat project is all set up, let's proceed with verifying our smart contract on the Sepolia network. But before we do that, we need to make a new file here inside the contracts folder. Let's name it my second token.sol. There we go. Let's just paste the code that we used a while ago. But here, we need to make a slight change to our contract to ensure the successful verification. Since if we were to use the same exact code with the same wallet address, we wouldn't be able to verify the smart contract. It's because the bytecode would be the same. So to avoid this issue, let's make a small alteration to the code, or you can use a different wallet if you want. Okay, so let's change here this one. Let's make it underscore name and then symbol. And then let's also add a constructor argument here. There you go. And then let's change this to my token. Okay, I think this is all good. So let's compile our code by running the command npx hardhat compile. Let's just wait for it to compile successfully. Okay, so it's now done compiling our code. So you'll notice here that it generated two new folders, which are the artifacts and the cache. So the artifacts folder, this contains the compiled artifacts of our contract, such as the bytecode, the application binary interface or the ABI, and other metadata or other relevant information of our smart contract. The cache folder stores the cache data from previous compilations to speed up future ones. By the way, to see the ABI and bytecode of our smart contract, you can navigate to the artifacts folder and then open contracts folder and then the mysectoken.sol and then mysectoken.json. Okay, so this is the ABI and bytecode of our smart contract. Anyway, we also made a .env file right here to store the RPC URL, private key, and API key. We also modified the hardhat.config.js to connect to the Sepolia network. And then the scripts folder, we have the deploy.js file. So we will also modify this one to connect to our smart contract. Inside the async function, we deployed the mysectoken contract using the hre.ethers.deploy contract. And then the name of the contract. Then let's add here the constructor arguments. Since we've changed a bit in our previous code, let's put here mysectoken and then the symbol MST. Okay, there. And then I think this is all good now. Let's try and deploy this contract. So we use the command npx hardhat run scripts / deploy.js -- network and then the test network name, which is the Cephalonia. Okay, there you go. This is the smart contract address of our MySec token contract. Let me just copy it here. And then let me copy the smart contract address. And then let's go to the Ether scan. Okay, so we're now here at Ether scan. Let's paste our smart contract address right here in the search input field, same as the process earlier. Let's go to the contracts tab, click the verify and publish. Okay, so here in the compiler type, this is where we will choose the Solidity standard JSON input. And then the compiler version that we used, let's say, what did we use there? Let's check in our code. So we used the 8.18, same as a while ago, and then the MIT license, then check continue. Okay, so here it will prompt us to input a file. Now let's go back to our VS Code. There. Let's go to the artifacts folder. And then select the build info, and then open the .json file right there. So here, let me just format this document. Okay, there. So let's collapse the input and the output. Okay, then I want you to copy the input object starting from the curly braces to the closing curly braces. Once you're done copying, click or create a new file in your root directory and name it input.json. So I have it here. Then let me just paste it again. So there. Then click save. And then let's go back to the Etherscan website. There. Then let's click choose file. And then let's select the input.json file that we just created. There. And then click to upload selected file. Okay, there you go. So as with the previous method, the constructor arguments will be automatically generated. For the miscellaneous settings, we have here the MIT as our license. Once everything is set, click I'm not a robot or check it and then click this button, verify and publish. So let's just wait for a while. And then there you go. The contract is now successfully verified and published using the standard JSON input method. So you can click this contract address link here to access the read and write functions of your contract. Okay, so this is how it looks. You might also notice that there's a difference between the flattening all the contracts into a single file and using the standard JSON input method. So when we flattened, let's go to our previous smart contract address. This is where we use the flattened method. You can see here that all the code is merged into one file, which is this one, right? So here it goes. This is the contract source code, all merged into one file. Meanwhile, in the JSON input method, each contract is shown into different or multiple files. So we have here our mysectoken.sol right here, and the other smart contracts are separated from each other. So there you go. And there you have it. That is how you verify a smart contract using the flattening into a single file method and the standard JSON input method.